Hi guys, welcome back to Mishler Math. Suppose you have a friend in the United States that's lived there all her life, and you're talking to her on the phone, and you're going like, "Man, it's 30 degrees out here," and she says, "Well, it's July. How can it be 30 degrees in July in Cairo?" And you're going like, "What are you talking about? It's 30 degrees. It's really hot." And they're going, "No, 30 degrees is really cold." And pretty soon you figure out that you're talking about 30 degrees centigrade and they're talking about 30 degrees Fahrenheit. Because in the United States we use Fahrenheit and here in Cairo you use centigrade. So that's when this great little formula comes up. Fahrenheit is equal to 9 over 5 times the centigrade plus 32. And of course you know that if you put 30 degrees in there, you just told her your friend it was 30 degrees, so you put 30 degrees in there, you go 9/5 times 30 plus 32, and you cancel. This is 1 and this is 6, okay, because 5 times 6 is 30, and 6 times 9 is 54 plus 32, and you do a little bit of calculating here, and then you add this up and you say, oh, well, okay, in Fahrenheit that's 86 degrees. And so now your friend's going, oh yeah, okay, 86 degrees, that's kind of warm, it's not too cold, not too hot, but it's kind of warm. And so you're going like, okay, so then your friend calls you and says, okay, wow, it was 59 degrees today. And you're going like 59, that's like super hot. How could it be 59 degrees? No, it's really cool. It's like we're wearing jackets outside. 59, man, that's like hotter than it's ever been in Cairo. And so you're going, oh, that's right, we got to convert again. So you're going like, okay, how do I find out if you're giving me the centigrade or the Fahrenheit? How do I find out what centigrade is? So you're going like, what is centigrade? And so back up a minute here. And so now we're going to find out how to find out what the centigrade is, and we're just going to solve this equation for C. Okay? You got F equals 9/5 times C plus 32. We're just going to solve this for C. And so we'll know what C is. When we get done, we're going to say C equals something. Well, how do we do that? Well, you subtract 32 from both sides. And so you have F minus 32 equals 9 over 5 times C. Okay? Well, if you multiply by the reciprocal, okay, 5 over 9, then this cancels, this cancels, this cancels, and this cancels, and you're left with C all by its lonesome over here. Okay? But you have to do that to the other side too, and 5 over 9. And so you can distribute this if you want, but it's real easy, and this is the way it's usually done in science. You just leave it like that. 5/9 times 32 equals C. Or C equals 5/9 times F minus 32. So when your friend says it's 59 degrees, okay, you plug that into this equation, and you get 27. And you get 5/9 times 27, okay? Because this is 5/9 times 59 minus 32. So 5/9 times 27, cancel here, and you go, whoa, that's 15 degrees. Yeah, you're right. That's kind of on the cool side. If it's 15 degrees in Cairo, you see most people wearing jackets. Well, ladies and gentlemen, what we have just done here is we have found the inverse of this function. Okay, get rid of that. F equals, what did I say that was? 9/5 C plus 32. And I said that C, centigrade, is equal to 5/9 F minus 32. Okay? Fahrenheit minus 32 degrees. So these two are inverses of one another. Okay? And the way to find an inverse is real simple. Okay? Inverse of a relation. And notice I say relation because an inverse, or a relation can have an inverse, and one might be a function, both might be a function, or neither one would be a function, okay? So we don't always say it's a function or inverse of a function. So I'm going to show you something here. If I do this, that's a bad one. I think I can do better than that. Let me see if I can do better than that. All right, let's try it again. That's a better bracket. If I do a bracket and I put this in here, this is like set notation. So I got 2 comma 5. This is an ordered pair, of course. I got 3 comma 9. I've got 4 comma 13. And I've got 5 and 17. Okay, and then close the bracket. Now this is a set. We call this is a relation. Now right away you can look at this and you say, well, is this a function? Yeah, it's a function because I got 2, 3, 4, and 5. I don't have any repeats on my input variable. So that's a function, but that's not important right now. The important thing is, how do we find the inverse of that? Well, the inverse is real simple. Watch. 5, 2, 9, 3, 13, 4. And what do you suppose this is going to be? Yes, 17 and 5. So this is the inverse of this relation, okay? You notice all I did was swap x and y. Okay, I swapped the input variable and the output variable. Now the domain of this first relation is 2, 3, 4, and 5. The range is 5, 9, 13, and 17. The domain of this one, okay, is 5, 9, 13, 17. And the range is 2, 3, 4, and 5. Now, what do you notice about the domain of the first relation and the range of the second relation? You notice the domain of the first becomes the range of the second. That kind of makes sense, doesn't it? Because you're talking about x and y, and we're swapping the two. So that's how we find the inverse of a function. So let's try something else here. And this time, I'm going to show you how to find an inverse using algebra. This thing called algebra. Al-Khwarizmi is a guy that invented that. If you don't like algebra, go holler at Al-Khwarizmi. Okay? So y equals 4x minus 5, and we're supposed to find the inverse. Okay? So, well, let's see. We do this the same way we did the except that we've already got y equals 4x minus 5. So let me give you some steps to help you know how to find an inverse. Step 1, okay, to find an inverse is you switch the x and the y, because remember I said if you want to find the inverse, you switch the inverse. And then step 2, solve for y. So, well, what are you talking about doing? Let's switch the x and the y here. We're just going to switch those back and forth. And so that gives me x equals 4y minus 5. And now I'm going to solve for y. Okay? Well, add 5 to both sides. I have x plus 5 equals 4y. And then divide both sides by 4. Cancel. I have y equals x plus 5 over 4. Now, if I want to put this in slope-intercept form, I can say, well, y equals x over 4 plus 5 over 4. That's supposed to be a 5, by the way, not an s. Sorry about that. Doesn't look real clear. But this is the inverse in slope-intercept form. Now, I'm going to rewrite these over. I guess I can leave them there. And watch, I'm going to show you something. It's really kind of cool. Okay? I'm going to graph both of those. Okay? So watch this, because this is really incredible. Y equals 4y minus 5. That was my first one. Okay, so clear, because I had some other stuff there, and clear. And y equals 4x minus 5. That's my original function, right? Y equals 4x, original relation, function, whatever. We don't know, we don't have to worry about whether it's a function or not at this point, okay? We will. And x over 4, that's the same as 1/4 x, isn't it? Or I can do it either way. I can say, okay, x over 4 and plus parentheses 5 over 4. Now, I don't have the ability to create fractions here that you do have on the TI-84, so I'm just going to leave it like this, okay? Now, I'm going to graph both of these. I want you to take a look at something. It's kind of interesting. When I graph it, there's the first one. There's the second one. Now, you say, well, yeah, but this doesn't mean a lot, but take a look at something here. I'm going to graph y equals x, okay? And graph that, and look at what that does. First of all, it goes through the intersection of these two lines. Secondly, if you look at this, it would be the reflection of this first line over this line, y equals x. These two are reflections of each other. You think about this, this kind of makes sense. Now I'm going to go zoom square, and you'll see it even better. Okay, there's the first graph, there's the second one, and there's that y equals x line. You notice you notice the symmetry there? These things are inverses of one another, and so they reflect across this line y equals x. Now, this is what's interesting. Okay, now you say, well, I know that this is a function because you know this is just a linear relationship, 4x minus 5. And I can kind of tell that the second one is a linear relationship. So the question is this a function? All you have to do to find out if the inverse is going to be a function is to give it what we call the horizontal line test. Now, so you don't get confused with all this stuff, remember the vertical line test tells me, is this a function? For example, this is y equals x squared. Well, it's supposed to be y equals x squared, okay? So, is this a function? Well, yeah, because if I put a vertical line anywhere here, I'm only going to pass through the graph one time. Well, the horizontal line test goes like this. The horizontal line test is to tell me whether the inverse is going to be a function. And to do that, I put a horizontal line through this and say, look, it passes through it in 2 points. So that means the inverse of this is not going to be a function. Okay, now it turns out the inverse of this, y equals plus or minus the square root of x, that's the inverse of this function. And if I graph that, plus or minus the square root of x, looks like this. Okay, so you can see that that is not a function because it doesn't pass the vertical line test. So, but I don't even need to go this far. I can just look at this and say, does it pass the horizontal line test? If it doesn't pass the horizontal line test, that doesn't mean it's not a function. It means its inverse is not a function. And then there's a couple more things I want to show you here. And this is the identity function. You remember I said that graph y equals x? Well, this is I of x equals x. Or, if you put it in your calculator, it's y equals x. That's what that is. And that's called the identity function. Okay? And what do we do with that? What we do is we say that if f and g are functions, okay, f and g are functions, okay, and FOG is equal to GOF, or the f of g is equal to g of f, and they're both equal to x, that means f and g are inverses of each other. Okay? Well, what does that all mean? What does that have to do with us? Well, let's take a quick look at how to solve something here, or how to test. So let's say f of x equals negative 5x plus 7. G of x equals negative 1/5 x plus 7/5. And you say, well, I want to know if these are inverses of each other. So I say f o g, that's f of g of x, okay, equals negative 5 times g of x plus 7. You see, I just put this, 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 this. And what does that equal? It's negative 5 times, what's g of x? Negative 1/5 x plus 7/5. Okay, plus 7. And what does that equal? Let's take a look. We got negative 5 times negative 1/5. Negative times negative is a positive. 5 times 1/5 is 1, so that gives me x. Negative 5 times 7/5 is a negative 7, because negative times a positive is a negative. 5 times 7 over 5, you just cancel the 5s, and you get 7. But then I had the plus 7 out here. Negative 7, positive 7 equals x. So FOG of x equals x. Well, let's see what the other one looks like. Okay, what about GOF? Well, that's G of f of x. Okay, and let's see what that equals. If G of x is negative 1/5 x plus 7/5, then G of f of x will be negative 1/5 times f of x, negative 5x plus 7 plus 7/5. What does that equal? Okay, negative 1/5 times negative 5 is a positive, or excuse me, negative 5x is a positive x, right? Negative 1/5, negative times a negative is a positive, 1/5 times 5 is 1. 1 times x is x. Negative 1/5 times plus 7 is a negative 7/5. And then I have a plus 7/5. Some of you have already figured out where this is going. We end up with x. And so that means that yes, G of f of x and FOG of x both equal x. And so that means they are inverses of each other. We'll talk more about this in class tomorrow. This one went kind of long, had a lot to show you. Sorry about that. Thanks for hanging in there. Bye.